This is Dr. Martin's second supplemental lecture on membrane transport. I was talking about forms of transport that actually involve parts of the membrane, larger parts of the membrane than just the protein. And I mentioned exocytosis and endocytosis. So we're going to look at an example of exocytosis in a nerve cell, or a neuron as it's called. Nerve cells are highly unusual in their shape. They have most of the cytoplasm and nucleus. Organelles is located at one part of the cell, and there's a very long extension that's called an axon. You don't need to worry about that. And at the very end, there's a number of knob-like projections that contain membrane vesicles, and within them, as you can see here, we have chemicals that are called neurotransmitters. These are like dopamine, serotonin, maybe you've heard of some of those. So what happens is that a nerve impulse will travel along the axon, and it will actually trigger the movement of those vesicles to the end membrane. So these are going to move to, they're going to dock essentially along that membrane. And when they dock, they fuse with, the membrane vesicle fuses with the membrane of the end knob, and an opening appears, and the substance that's contained is going to diffuse out into the space that is between another neuron or another muscle cell. So that is exocytosis. So we're moving substances out of a cell across the membrane, and it involves membrane vesicles. All right, so let's take a look at a different type of transport that does involve membrane vesicles, and this is called endocytosis. So here's our cell. In this particular case, we have the opposite. We're going to move substances into the cell, and